type is redox. Redox is going to be a reduction with an oxidation. There's several ways to know you're going to have a redox. One is if you have an element by itself, that element has an oxidation state of 0 because it hasn't lost electrons to anything, it hasn't gained electrons from anything, so it can't be a positive or negative charge, it's a 0. For that element to react with something else, it's bonding. Bonding is rearranging your electrons and then gaining an oxidation state. So if you see anything by itself, if you see two types of transition metals, that's a really good indicator because they can have multiple charges. So let's see, look for one element that's alone. Look for transition elements. Also, there's going to be, I'll give you a list of things on your stuff I should know for the AP sheet that you find on chemibear.com. There's a list of strong oxidizers on the right side of the sheet, halfway down. If you see those things, you have a redox. The other one is make sure you know charges of metals. So know that lead can be a 2+ or a 4+, the 2 is more common. Copper can be a 1 or a 2+, 2 is more common. Tin can be a 2+ or a 4+, 4 is more common. Iron can be a 2+ or a 3+, and the 3 is more common. So that means these guys can be any of these oxidation states or 0, which gives you a lot of options for what can be oxidized, what can be reduced. As soon as you know I found something that's going to be oxidized, look through your reaction to see what can be reduced, vice versa. So on your ChemiBear sheet, when it says strong oxidizers, these guys are all strong oxidizers, but like there's a bunch of them. I feel like these are the most important, so I would memorize. If you can memorize all of them, cool, but there's so much that you have to take in that I'd prioritize. Permanganate ion in an acid solution makes manganese 2+ in water. Dichromate, that's Cr2O7 with a 2- charge, in acidic solution makes chromium 3+ in water. So the chromium, well, we'll see what's happening. In hydrogen peroxide, I would memorize that decomposes to water and oxygen. Let's see why. So in permanganate, the manganese has a 7+ charge. So manganese gets reduced to a 2+, meaning something has to be oxidized. So we would pair this with something that could be oxidized. For example, iron 2+ could be oxidized to iron 3+. Manganese dioxide, the manganese is, or sorry, this is manganese 4 oxide, my bad. This manganese, because the 4 is telling you the charge of the manganese, this manganese is a 4+. It gets reduced to a 2+, so it would oxidize something else. Something else would have to lose electrons for the manganese to be reduced. This chromium, the chromium in this dichromate ion is a 6+. It gets reduced to 3+, so something else gets oxidized. And in hydrogen peroxide, I can see that the oxygen goes from being a 1- to a 2-, so that oxygen is reduced. If the hydrogen peroxide is by itself, the oxygen both gets reduced and oxidized, it gets split up. But if it's with something else, your hydrogen peroxide will turn into water, so the oxygen gets reduced and you oxidize something else. So you want to know those. Let's try some. Okay, a strip of zinc is placed in a solution of nickel 2 nitrate. As soon as we see solution, we know we have to be aware of the spectator ions. They don't do anything. So zinc is just Zn in a solution of nickel 2 nitrate. So that's nickel with 2 nitrates. Nitrate is a 1 charge. The nickel 2 is going to be nickel 2+. So that's going to react. This zinc is a metal that's all alone. So I know that it has to be oxidized or reduced. Metals get reduced. So that turns into, zinc 2+. So that means it would take on 2 nitrates. So zinc 2+ with 2 nitrates and O32. And the zinc is swapping places with the nickel. That leaves nickel by itself. And then I can see that I've got this aqueous solution here. It's still aqueous over here. That means the entire time nitrate did nothing. So I go ahead and write the spectator ions, or I cross out the spectators, which is nitrate. Zinc was by itself. Nickel was a 2+. It reacted. The zinc was oxidized to zinc 2+, and the nickel was reduced. Next, a solution of copper 2 sulfate. So it's aqueous, I have to remember for my spectator ions. CuSO4, that's copper 2 sulfate. Sulfate is a 2- charge. I'm going to put aqueous so I don't forget. that this could be spectators, is spilled onto a sheet of freshly polished aluminum metal. So aluminum. Aluminum's by itself. It's going to be oxidized or reduced. Metals tend to be oxidized because metals are on the left of the periodic table, so they're going to have fewer protons for the amount of shielding they have, meaning it's easier for them to lose an electron. There's less attraction for their outer electrons. Aluminum forms a 3+ charge when it's oxidized. So since the aluminum is oxidized, something needs to be reduced. Copper 2+ can be reduced. I'm going to reduce it down to just copper. I think it'd be okay if you made it copper 1. I don't think there'd be anything wrong with that. And then I'd have aluminum sulfate would be the solution. So the sulfate was aqueous on the left. It would be aqueous on the right as well. So I can just get rid of the spectator ion. So I'm going to take the sulfate out. And that means I'm starting with copper 2+ and aluminum. I end up with aluminum 3+ and copper. So now I'm going to go ahead and balance this for charge. So I'm going to say the 2 aluminums are reacting. That makes a 6+ on the side. And I'll say 3 coppers are reacting, making a 6+ on that side. So now, 3. So now it's balanced. Charge is balanced. 6+ on either side. Next, it's tricky. An acidic solution of potassium dichromate is added to a solution of aluminum 2 nitrate. So this is where, if you don't know those equations from the gummy bear, the strong oxidizers, it's a little intimidating. So acidic means there's an H+ in there. Potassium dichromate. I'll go ahead and say alkali ions don't do anything. So I'm going to leave the potassium out, just like I tend to leave nitrates out. It won't do anything. That's a spectator ion, guaranteed. If it were potassium metal, super reactive. It's going to be oxidized. But this is an ion. Okay, so dichromate. Dichromate is Cr2, oops, that's a C2. Cr2O7 with a 2- charge. 2-. Dichromate is added to a solution of iron 2 nitrate. Nitrate won't do anything, it's a spectator. So I'm going to go Fe2+. Okay, so something has to be oxidized, something has to be reduced. I'm going to break this into my oxidation reaction, my reduction reaction. So iron 2+ can be oxidized to 3+. I also just know the iron's going to be the oxidized thing because I know this is a strong oxidizer. So it's going to oxidize this. That means the thing being reduced is this guy. So dichromate, Cr2O7 with a 2- is going to be reduced. Just from seeing the sheet, memorizing that dichromate turns into chromium with a 3+, I can balance the rest of this. I have 7 oxygens on this side. I need 7 oxygens on this side. There's water present in an aqueous solution, so I'm going to have 7 waters. Now I've got a bunch of H's on the right side. I even have that it's an acidic solution, so I'm going to put my H+ on this side. So I'll put 14. Now I need to balance the charge. Ooh, I didn't balance my chromiums. There's 2 chromiums here. Here's 2 chromiums. Okay, so it's a 6+ on this side. And then I've got 14 minus 2. I've got a 12+ on this side. I've got to bring this down to being 6+. So let's add 6 electrons. All right, so I've got 6 electrons being gained by this dichromate that's being reduced. I need to produce 6 electrons on here. So for every 1 iron 2+ that goes to an iron 3+, it's just giving up 1 electron. Let's do this 6 times. Then I can say 6 electrons were produced and then consumed. The half equations are balanced, the electrons are balanced. So the overall reaction is 14 H+'s react with 1 dichromate, Cr2O7, 2-, and 6 iron 2 ions to make 6 iron 3 ions, 2 chromium 3s, and 7 waters. And you should definitely check and see if your charge is balanced and make sure the whole thing's balanced. So I would do that, except for I only get 15 minutes per video. Next, we have a bar of strontium metal is immersed in 1 molar copper 2 nitrate solution. So strontium, Sr, strontium metal, it's all by itself. Oh, this must be a redox. Yep. Okay, so strontium is with copper 2. The nitrate's not going to do anything. Won't. Spectator ion. Okay, so I can see that this guy's going to be oxidized. This will be reduced. Strontium forms a 2+ charge when it's oxidized. I know that because it's an alkaline earth metal. It's in the second column. So that means the copper, I could either make it a 1+ or just make it 0. I believe they're both acceptable. It's balanced. Next, we have a solution of hydrogen peroxide is exposed to strong sunlight. That's their way of telling us it's going to decompose. So we know that hydrogen peroxide, this oxygen's a 1-. I'm going to reduce some of that oxygen, make water where oxygen's a 2-. So that means I need to oxidize something. I'm going to oxidize the rest of the oxygen to make O2, which is neutral. So that means I'm going to need 2 hydrogen peroxides to make 2 waters and 1 oxygen. There's no aqueous stuff in here, so I don't have to worry about spectator ions. Done. And one more. Okay, so acidified solutions of potassium permanganate and iron 3 nitrate are mixed together. So this is another one of those, if you memorize a few of the strong oxidizers, you can do these. And they're not hard, but you know, how many are you going to memorize? It's up to you. Acidified means I have an H+. Potassium ion, not going to do anything. Permanganate is MnO4, it has a 1- charge. And iron 2, that'll be Fe, as a 2+. And nitrate is not going to do anything, that's going to be a spectator ion. Okay, so I know this is a strong oxidizer, meaning this is probably being oxidized. And iron can be oxidized. Iron 2+ can turn into iron 3+. I didn't make these up, I just went backwards through AP tests and grabbed the most recent ones in the selection I had. So you can see this guy shows up a bit. So then that means the thing being reduced is the permanganate, MnO4, 1- is permanganate. And I look on that sheet, stuff I should know for the test, and I learned that for manganate, the manganese goes from, it was a 7+ here, to being a 2+. Okay, so there's its reduction. So now I can go ahead and balance these. 2+ here, 3+ here, I must have an electron. And then for this guy, I've got 4 oxygens, so I'm going to need to put 4 oxygens over here in the form of water, because there is water in this solution. Now I have a bunch of hydrogens that only show up on this side, so I'm going to put 8 H+ over here, and that works well because we said it was acidified. Then we balance the charge. This is 8+ minus 1, so this side is a 7+, this side is a 2+. Since this side is 5, charge is more positive, I'll add 5 electrons to bring it down to being a 2+ on both sides. Now I can say I'm consuming 5 electrons, I'm going to need to produce 5 electrons. So we'll do this step 5 times. So those 5 electrons that were produced are being consumed, and the reaction is done. So I can see I have 8 H+ plus 5 iron 2+, reacting with MnO4 with a 1- charge, permanganate, to make 3 irons with 3+ charges, a manganese 2 ion, and 4 waters. And that's time. Woo. Check and make sure it's balanced. I definitely will before I post this.